collect notes. In class, we're going to collect the homework, continue notes on concentration and molarity, and then do a worksheet on molarity. So concentration. This indicates the amount of solute that's dissolved in a given quantity of solvent. The word that's underneath the picture there is solvent. Dilute. When you have something that's dilute, that means you have just a small amount of solute. Concentrated. When you have a large amount of solute in the solution. These are terms we pretty much use every day. Something is very diluted or something is very concentrated. Colligative properties. Colligative properties are properties that depend on the concentration or how much of the solute you have in a solution. In class, we're going to watch a video on colligative properties. Boiling point elevation. When you add a substance to a liquid, it's going to create a situation in which the molecules of the liquid will be attracted to the particles of the substance that's dissolved in the liquid. This is going to cause the boiling point of the liquid to be higher than a normal liquid boiling point. The more substance you add to the solution, the higher the boiling point will be. Freezing point depression. Adding a substance to a liquid will also cause the normal freezing point for a liquid to be lower than normal. The particles will interfere with the molecules of the liquid, changing from a liquid to a solid phase. And this is why we salt roads in the winter. The salt water has a lower freezing point than water does. So when we add substances to the water as it melts, it will have a lower freezing point, which means our roads will stay wet instead of icy. How to separate things is another short video we'll watch in class. Remember that concentration is a measurement of the amount of a solute that's dissolved in a given quantity of solvent. We'll also watch a molarity video, which will walk you through the steps of how to calculate molarity, but we're going to walk through that here in the video also. Molarity. In chemistry, molarity is the most important unit of concentration. Molarity, which we're going to abbreviate with a capital M, is the number of moles of solute dissolved in 1 liter of solution. Molarity equals, in your notes you've got a space there in the box, so molarity equals moles of solute to liters of solution. If you're looking at your back of your periodic table, you also have that listed right there. Molarity equals moles of solute over liters of solution. The important thing to remember is that the volume is the total volume of the resulting solution, not just the solvent alone. Let's look at how you would make something of a certain molarity. If we were going to make a 0.5 molar solution, the first thing we do is we would measure out 0.5 moles of the solute to a 1 liter volumetric flask that's half filled with water. We want to half fill it with water because we want our substance to dissolve. To get 0.5 moles of the solute, we would measure out the weight, we would calculate the weight of the substance and then measure out half of that weight. So we would have 0.5 moles. The next thing we would do is we'd swirl the flask to dissolve the solute into the half-filled liquid. And then we would fill the flask to a mark that's etched in glass on the volumetric flask, and we'd fill that right to exactly 1 liter. Notice also that this is the meniscus of the fluid, and we want the meniscus of the fluid to be touching that line. So this is where we're going to measure. Performing calculations with molarity. What's the molarity of a solution that contains 0.25 moles of salt in 0.75 liters of solution? First, we're going to identify what are the things that the question gives us. We're going to need to use capital M, which will equal molarity. It's giving us moles, and it gave us liters. So what we're going to need to calculate is the molarity. The molarity of a solution is equal to the number of moles divided by the number of liters. When you put that in your calculator, your answer will be 0.33 moles per liter, or in a shorter way to write this, 0.33 molar, or 0.33 molarity. What volume of a 1.08 molar potassium iodide solution would contain 0.642 moles of potassium iodide? Well, we're going to first write down what we know. We're going to need to have molarity, we need to have moles, and we need to have liters. We're going to substitute in what we know from the equation. We're given the molarity in this one. We're also given the number of moles, and we have to find the number of liters. We plug those numbers into our calculation. And when we solve for this, we're going to cross multiply to solve for this. So it's going to be 1.08 times liters. This is going to cross multiply with the pretend 1 that's underneath here. And then we're going to divide. And our answer will be, the volume should be 0.594 liters. Again, 3 significant figures, because that's what we have in our question. Let's look at one more. How many grams of calcium bromide are dissolved in a 0.455 liters of a 0.39 molar calcium bromide solution? Let's pull out the information that we need. We're given the molarity. We have to find the moles, and we're given the liters. So the first step is to go ahead and find the moles. We put that in our calculator, and we find that the number of moles, with the right number of significant figures, is 0.18 moles of calcium bromide. Well, remember, our problem asks us for grams, so we're going to need to find out how many grams that weighs. This becomes just a very short dimensional analysis problem. We've got our moles of calcium bromide. We're going to need moles of calcium bromide on the bottom. And now we're going to need to calculate how much a mole of calcium bromide would weigh. When you look at your periodic table and add everything together, 1 mole of calcium bromide will weigh 199.88 grams. We put that in our dimensional analysis, and the final answer will be 36 grams of calcium bromide. We're going to look at another PhET simulation to talk about concentration in class. Molality. Molality is symbolized by a small letter m, and it's usually written in italics. And this is the number of moles of solute per kilogram of solute. To solve this, you're going to have the molality will be the solute number of moles divided by kilograms of solvent. This is kind of an unusual concentration. You see molarity much, much more often, but you need to be aware that molality exists also. This formula is also on your periodic table. Parts per million or parts per billion. Concentration can be described by grams of solute molecules per grams of solvent. Here's an example of a question you might see. There are 25 grams of a chemical is added to and dissolved in 75 grams of water. What's the concentration of the chemical in parts per 100? Well, we've got 25 parts, that is our solute. Our total volume, or total weight, would be 25 plus 75 times 100 for our parts per 100 is going to give us 25 parts per 100. Suppose 17 grams of sucrose is dissolved in 183 grams of water. What's the concentration of sucrose in parts per 100 and parts per million? Well, we've got 17 grams divided by our total weight, which is going to be 17 plus 183. We want parts per 100, so we're going to multiply the answer by 100, and that would be the answer in parts per 100. For parts per million, it'd be 17 divided by 17 plus 183, so there's our total weight, multiplied by 1,000,000. And that will give us the answer for parts per million. You can put that in the calculator and figure those answers out for yourself. Then we're going to look at a TED, how to look at parts per million in class. If you want to copy and paste this, you should be able to copy and paste this if you want to see the video for yourself. And then finally, we're going to do a molarity worksheet for homework.